Good morning. How are you guys? Hope you're doing well. Today the videos are for 7.7c, which is actually graphing an exponential function. Instead of a line, like a linear function, or an absolute function, which makes a big V that opens up or opens down, or a quadratic function, which is a parabolic shape. It's in the sheaf above parabola. Today we're working on exponential functions. So we're going to look at the ones that look like growth, they show growth, and we're going to look at the ones that show decay, okay? And they do look slightly different, okay? So first off, let's look at some different shapes. I think that's a good way to start. So I've posted a lot of stuff under this lesson, 7.7c. We did do an activity in class, which I'm not doing on video. You're welcome to come in at lunch and do that activity with me if you'd like. And then there were two other worksheets you had to pick up. One that says, on your own. Do you see that up there in the corner? On your own. This would be your homework assignment. You do not have to do the last three questions. So the homework assignment says, on your own in the corner, and I've already put this online, on your module under 7.7c. You really only have 4 things to graph and answer the 2 little questions under each, and then you have to identify these 4 graphs. And your choices are linear, exponential growth, and exponential decay. Okay, so this is your homework, only 5 questions basically. 1, 2, 3, 4, and then this 5th one where you identify. And again, you don't have to do the bottom piece. Perfect. Your notes look pretty similar. So it says growth tables, graphs, evaluating equations, and again, the one that says on your own is your homework. So let's get started. I'm going to flip it over and look at the top here. So it says identify each function as linear, growth, or decay. So linear means that when you graph it, it forms a line. So let's see if any of these graphs form a line. We got the first one. It is actually a line. It's linear. It's a straight line. So this one is in fact a linear function. Cool. Let's look at this one. I see a beautiful curve. When I see the curve, I know that it is exponential. But is it exponential growth or is it exponential decay? So in English, we read from right to left. That's the same way we're going to read these graphs. We're going to start, sorry, I said that backwards. In English, we read from left to right, and we're going to read this graph moving from left to right and see what it does. So I can see that this graph starts low. It literally starts at this 0 here, and then it goes very high. Since it starts low, L for low, and then it gets high, I can tell going from left to right, just like we read in English, moving left to right, that this one is a growth graph. It's showing growth, exponential growth, and it's rapidly growing. It's very quick. Let's look at this beast. Again, we read from left to right in English. We're going to read graphs from left to right as well. So here I am at 0, and this one looks like it's going, woohoo, spinning up. Perfect. So that one is also indicative of growth. Last one. Again, let's read it from left to right. Start left and move right. I can tell that this one starts high and then is swooping down low. So this one is indicative of decay. The graph is going D for down, okay? Decay, D for down. So we have linear, we have growth because it's moving in an upwards direction, and because this one's moving in a downward direction, it's decay. Now let's flip this over and do some actual graphing. Let's actually graph. Cool. None of the rest of this back page I'm going over. I'm focusing my lesson today on just graphing and answering these 3 questions, okay? Okay, so let's take a gander. Now, you can use a calculator if you like. For some kids, that might make this task a little bit easier. So I'm going to make this a little bit closer. Too close, too close. Okay, and see how we do here. So we have this function to graph. They like us to plug in -2, -1, 0, 1, and 2. So that literally means I'm going to put that -2 in that spot. So it's going to turn into this. Now you can put that in your calculator. The way you would do that is 2, look for this symbol, and then that raises the next number that you enter to be an exponent, hit the subtraction sign, and then 2, and then equal sign, and it will give you the answer to this. So you have that option. You can use a calculator during the test to graph, if you'd like, okay? You can also use the rules of exponentiation, which we know. A negative exponent cannot stay. It must go downstairs and become happy. And then we know that 2 squared is 4. I don't choose to use a calculator. I don't feel I need it. 1/4, now you can put 1/4 here, or I'm going to say what 1/4 is equivalent to as a decimal, 0.25. And that's what you get on the screen of your calculator. We can do the next one. Oh, what about when it's -1? It flips downstairs, and it becomes 1/2, also known as 0.5. And again, you can put this in your calculator. You don't have to use the rules of exponentiation if you don't want to. Anything to the power of 0. Do you remember what that is? Anything to the power of 0 is 1, equivalent to 1. Now, if I put a 1 in that spot, anything to the power of 1 is just that number. Cool. And then let's put a 2 there. 2 squared is 4. Beautiful. We have 5 points that we're going to go over here and now graph. And again, you can do all of this in a calculator. The only part that the calculator is not going to help you with is the actual plotting of the points. Now remember, this is going to be in the shape of a curve. We can tell that this is an exponential function. It is not of the form y equals mx plus b to make it a line. This is an exponential function with a growth factor of 2. So it's going to be growing pretty rapidly. Because if it's this number in parentheses is greater than 1, we already know it's growth. So let's plot this one. It says, go to -2, done. Go up a little bit. Because we can't go all the way up here, that's 1. And it's not 1, it's a bit of a 1. Now, -1, go up halfway. 0, 1, 0, 1. We just found our y-intercept. A y-intercept is the point where the graph crosses our y-axis. Cool. 1, 2. Over 1, up 2. Yeah, I can start seeing that curve forming. And then we have 2, 4. 2, 4. Now, the way that you graph it is very important. A lot of kids think that they're going to graph it like this. No, I wouldn't give that credit. I'm just going to be honest. There is something that's invisible here. It's called an asymptote. And it is a boundary that can't be crossed. It's like when you were 2 and 3 years old and you played hot lava in the living room, right? And you had to jump from couch to couch because you couldn't touch the floor because the floor was hot lava, right? Remember that? So this line is a hot lava line. It's an invisible boundary that cannot be crossed called an asymptote. So I'm going to start from the top and watch me. Don't touch the hot lava. Boom! You can never cross this line. This is the hot lava line. So it starts high and it goes, and it skins the surface, but doesn't touch the hot lava. How'd you guys do? Good? You should try 2 and 3 on your own, and we'll see how it goes. Oh, we should answer these questions. What is the y-intercept? It's 0, 1. That's where it crossed that y-axis. What is the multiplier or common ratio? Well, another word for that is the growth factor. I prefer growth factor. Growth factor is the number within the parentheses. That would be 2. You should try 2 and 3, and you should answer questions A, B, and C over there if you feel comfortable with that. Okay? Cool. I'm going to come back with video number 2, and then we'll finish this up. Okay? Thanks. Bye.